right, this is part 2. So we already did all of this. Our equation was y equals 5x minus 2. Our goal was to find xy combinations that work for the equation. And we did that by putting in a value for x. So like, for example, I put in -1 for x, and then I evaluated the right-hand side of that equation, which the value of that 5 times -1, and then subtract 2 was -7, so that's the y value. I did that for all 4 of those. Okay. So now we want to take, this is the same points, not quite as tidy, but that's okay. Same points, and now we're going to graph them. So remember, so this is the point -1, -7. This is the point 0, -2. This is the point 1, 3. This is the point 2, 8. And remember, when we're graphing points are always the x value is first, the y value is second, and the point is where that x and that y value cross. So already I can see that I made my graph a little wonky, and that's okay. So -1, -7, I'm going to go back 1, and then I'm going to go down 7, because this is -1. Go ahead and make this go down a little further. -1, 2, 3, 4, 5, 6, 7. This is -7. So the point then is where that -1 line, the -7 line, the point where those both come together is right there. So that's the point, -1, -7. The next one is 0, 2. This is 0 on the x-axis, so I'm going to go down 2. And you can label your points if you want to. You don't have to label your points. And then 1, 3. So this is 1. And then we go up 1, 2, 3. So this point right here is the point 1, 3. And then 2, 8. So 2, 4, 5, 6, 7, 8. It's going to go right here. And if you know your equation is linear, which we do because we're learning about linear equations, and I'm telling you it's linear, if you know your equation is linear, then you should be able to, all of your points should line up on a straight line. That's how you know you've done it correctly. And this here's a graph of the line y equals 5x minus 2, or a graph of the relationship y equals 5x minus 2. Every point on this line, like for example, this one right here, this is probably 1 point, I don't know, 1 point something, comma 4. It's a fifth. It's probably 1.2, comma 4. Because if I do 5 times 1.2, I'm going to go ahead and do that on my calculator. 5 times 1.2 is 6. And then if I subtract 2 from that, I get 4. So if the input is 1.2, the output is 4. Every point on that line makes this equation true. Cool. So that's how you graph it. And then the last thing that I wanted you to learn today was to start making connections between, and I'll color code these. I'll do slope in orange, and I'll do the y-intercept in dark green. And I'll remind you things that we know about slope. Slope is rise over run, which is the same thing as the change in y divided by change in x. And it's also the rate of change for the relationship. So as we're looking to find the slope, if I was going to go to find the slope between these 2 points, the rise is 5. It goes up 5. the run is 1. Oh, it's also called m. So the slope is 5 over 1, or 5. I can find it in the table. From -7 to 2, it goes up by 5. From -2 to 3, it goes up by 5. From 3 to 8, it goes up by 5. Each time these go up by 1. It's getting a little small, I know. Slope is 5, so change in y divided by change in x. This is the change in y. That's the change in x. Change in y divided by change in x is 5 over 1, which is just 5. And that right there is the slope in the equation. Y-intercept's a little bit easier. The y-intercept, I'll put things that we know about the y-intercept up here. Y-intercept is called b. It is the starting value. And it's the y value when x equals 0. Then the y value is the b value, is the slope, is the y-intercept. So right here, this is the y-intercept, and it crosses at -2. So the y-intercept is -2 because it's at -2. So I got the point 0, -2. That's the b value. I can see that right here. -2 is the b value. And then right there, the b value is -2. One thing that students are learning about linear relationships, one thing that some people have told me is confusing, is that, well, I guess I just want you to know, like, the relationship, it has a slope and a y-intercept. And you can find that slope and y-intercept by looking at the graph. You can find the slope and the y-intercept by looking at a table. You can find the slope and the y-intercept from a graph. Any of these representations, they all represent the same relationship. So they all have the same like characteristics, but those characteristics look different because it's a different representation. But it all is kind of circling around and coming back to the same thing. So if that was confusing for you, just remember that if graphs are easy, use graphs. If tables are easier for you, use tables. If equations are easier for you, use tables, and they all connect with each other. So sometimes you can use a representation that makes more sense to your brain to help you understand a relationship that makes less sense to your brain. And then, yeah. Okay, well, there you go. Good luck.